Hello everyone. Today we're going to learn how to graph tangent. So before we begin, go ahead and look at this transformations and identify what do each of these negative, the for the 1/2 and the +1 do to our function. So hopefully you went ahead and found out that the the negative itself is a reflection about the x-axis. The 4 in front of the cosine, that right there is a vertical stretch. Oops. Vertical stretch. Okay. The 1/2 is inside my parentheses, so that's going to go ahead and tell me that I'm going to have to go ahead and do some horizontal dilation. So keep in mind, this right here tends to lie to you because if I think about 1/2, I'm thinking about the horizontal is going to go get smaller, but in reality, it was a stretch by a factor of 2. Remember, it is a reciprocal. Opposite of what we think of, but the reciprocal. Okay, the +1, that is a vertical shift, 1 up. Okay, so we have all of that right here. Now, keep in mind, this is not the first time we see these transformations. As I mentioned in Unit 1, transformations will not leave us, not even until the end of the year. We'll still be using transformations. So if this is something you struggled in, please refer back to the other notes, the other videos where we talk about transformations more in depth. Okay, so let's go ahead and begin. For my week at a glance for my students that learn live with me in class, this is what we saw. Okay, keep in mind we have the PSAT for the students that are back with us on campus, and we have a unit exam for what we learned this entire unit. Okay, so we're going to continue to use critical points to graph our tangent function. Okay, so before we begin, go ahead and draw this out, write down these notes while I hide my video panel and everything to get more space. Awesome. So go ahead and write this down. Keep in mind, we're working with X and Y coordinates. Those X's are horizontal. They remind us of cosines. Those Y's are vertical. They remind us of sines. And tangent of theta equals Y over X. Okay. So we have this right here. So what I want you to know is the following. That this right here, this coordinate, this X and Y is 1 and 0, right? Using what we know from the unit circle where this is our origin. This right here will have to be our 0 and 1 up. This right here will be our -1 to the left, 0 in height. And this right here is 0, -1. Okay, so from here, we're going to go ahead and continue. And the next ones that, before I continue, I'm going to go ahead and label this right here is my 0 degrees. This is my pi over 2. This is my pi. This is my 3 pi over 2. And this also does 2 pi. The same location of full revolution right back at 0 is 2 pi. Okay. The next part is I want you to go ahead and notice these other points that I've labeled. Those right there are my 45. So pi over 4 is right here. And that coordinate is 1, 1. Okay. If I add another pi over 4, I get 2 pi. I'm sorry, pi over 2. And if I add another pi over 4, I get 3 pi over 4. And last but not least, this pi is the same thing at 4 pi's over 4. Okay. If I add one more, I get 5 pi over 4. Silly me, I forgot to put the coordinate at 3 pi over 4. That is 1 to the left and 1 up. Okay. 5 pi over 4, that is 1 down and 1 to the left. So -1, 1. Okay. If I'm at 5 pi over 4 and I add another one, I'm at 6 pi over 4, which reduces to 3 pi over 2. And if I add one more, I get 7 pi over 4. And that point is 1 to the right, -1 in the verticals, which is 1 down. Okay, so we have all of this. This is what I want you to know, that this is how we're going to go ahead and graph our tangent. So very similar to how we did sine and cosine, we will also do this in our form of a tangent. So go ahead and write this down while I label these points. So go ahead and write that down while I do these real quick. So pretty much I did all the same notes that we took from the last slide to this slide. Okay, now I'm going to go ahead and do that. What I want you to know is that tangent is my proportion of y over x, meaning I'm going to go ahead and have my y value in these coordinates be divided by my x values. Now, something that I really strongly recommend is that you always start graphing tangent with this negative pi over 2. Now, I'm going to go ahead and explain why in a little bit after we have our graph, but as of right now, just go ahead and take my word for it, and I'll explain later. Now, this negative pi over 2, I'm going to go ahead and say that here is where tangent starts, but I'm going to go ahead and refer to starts as just a period of this tangent, not exactly the entire function. Because as we know from sine and cosine, this tends to repeat as many times as you go to the unit circle, positive versions of the unit circle and the negative versions of the unit circle. Okay, so negative pi over 2, keep in mind, that's the same thing as saying 3 pi over 2, right? At 270 degrees is the same thing as negative 90. So according to this, my coordinate, right, that I'm going to go ahead and get my y over x is going to be negative, the point 0, negative 1. That's the same thing as saying negative 1 divided by 0. Now keep in mind, whenever you divide by 0, guys, you have an undefined. In this case, an undefined is resembled as a vertical asymptote. And this right here is negative pi over 2. Okay, let's go ahead and try the next one. Negative pi over 4, that's negative 45 degrees right here, negative pi over 4. My proportion for this, I'm sorry, my coordinate is 1 comma negative 1. So this right here would be the y value, negative 1 divided by 1. That is just a negative 1. So I'm going to go ahead and graph it at negative pi over 4. I have a value of negative 1. Okay. The next one that I have at 0, right, at 0 degrees, at 0 pi, I have 0, I'm sorry, the point 1 and 0. And if I divide y over x, I just have 0. So this right here, it passes right through the origin. Okay. Pi over 4, this right here, pi over 4. This is going to be my point 1 comma 1, which is the same proportions as 1 divided by 1, which is 1. So this right here is 1. Okay. For pi over 2, I'm doing it in red, and you probably should know why. We have the point 0, 1. And we have 1 divided by 0, which we know is undefined. So the reason I told you, hey, I want you to go ahead and write at pi over 2, to start at negative pi over 2, is because at the period of tangent, guys, it's just pi. Okay? And I accidentally forgot to put these labels. This was 0, and this was pi over 4. And the nice way to know is like, hey, if this entire distance from this asymptote, right, this vertical asymptote to this vertical asymptote, the distance of all of this is just pi, because we have half pi in the positive and half pi in the negative. In total, we have a whole pi. So that's the reason I tell you, like, hey, I want you to go ahead and start right here. Okay. Now we're not done. Let's continue this same procedure. Okay, I'm green. So 3 pi over 4. 3 pi over 4 is right over here. 3 pi over 4. And then my value is negative 1 to 1. And my value for this is my 1 divided by a negative 1, which is a negative 1. Right over here. This is my 3 pi over 4. If I do the same thing with my value here of pi, which is the point negative 1 and 0, I get that this will be 0. And hopefully you catch the same pattern, and you get to see that the next point at, would this be 5 pi over 4 would be a positive 1, because the negative 1 over the negative 1 equals 1. Okay. And then when you get to 3 pi over 2, you are dividing by 0. So you should have a asymptote at 3 pi over 2. And we said this was pi. and then this one was 5 pi over 4. Okay, so let's go ahead and sketch this out. So we have something like this. Something like this. Now, since we have this existing in the unit circle, we have the same pattern. It will be asymptote, right? The vertical asymptote. Then it'll be my pi over 4 negative will be a -1. Then I go to the midline, which is 0, then to its max, which would be 1, and then it goes to infinity. So maybe I shouldn't say max, but it would be our fake max, if you will. And it just copies that same pattern. Okay. So in a better graph of this, you can see that we have that tangent, right? It will be our function in red. So this is just a copy pasted version all over the entire number line. So if we were to talk about the domain, this domain will actually be all the real numbers except where you have these blue lines, which is your vertical asymptotes. So I guess you can say all real except for when our x's, right, our pi over 2, our x equals pi over 2, right? Because that's where the first one was. Whatever really doesn't matter where any of them was. Negative pi over 2, if you will. Pick a vertical asymptote. So this one negative pi over 2. And every single period, which we know is pi, and then we could just put a variable, I don't know, p, where p is a real number. Okay. Where p is a real number. So that means if you go ahead and multiply by 1p and add it to pi over 2, you get another asymptote. If you go ahead and put a negative pi, you get another asymptote, and so forth. Okay, how about range? Well, if we can see these red functions, go ahead and go all the way to the bottom. So negative infinity to positive infinity, that won't be an issue. Period is pi, that's how long it takes for this red line to repeat itself. And the vertical asymptote, we just said it was every pi over 2 plus our period times a variable, and you get to say that variable is any whole number, right? Negative and positive. Keep in mind, tangent is resembled as y over x, or also seen as sine divided by cosine. Okay, something that really messes up my students is that they struggle to find out what is a horizontal dilation. So keep in mind this formula right here will help you find it. The period of a period transformation will be defined by the value b, which we see here. The value b is the number that is multiplied or divided to the inside of our tangent, to our variable inside our tangent. So here we can see that the first two, these are horizontal compressions. So therefore our b will be those values. So in this case it is 2, and in this case it is 8. And that's where we can go ahead and find out that our pi value will be divided by 2. And you can see totally like, oh snap, this compression did work, because now my period, instead of being pi, it is pi over 2. Okay, the same goes for the other one, pi over 8. You will go ahead and compress it more times. Versus this right here, a horizontal stretch, we have pi divided by my 1/2, which is now, hey, I went ahead and made this way bigger than what it was, right? I horizontally stretched. Okay, so let's go ahead and graph some of these. I'm going to go ahead and assume that you have this right here by now. So I'm just going to go ahead and label these negative pi over 2, negative pi over 4. All I'm adding, guys, is pi over 4. So this pi over 4 plus another pi over 4, that is pi over 2. If I add another one, you can think about it like quarters, 50 cents plus a quarter, that is 3 quarters out of 4, right? If I add another one, then I get my pi. If I add another one, I get 5 quarters, right? Hopefully we got 3 pi over 2. Okay, so I have all of this. The next thing I want to go ahead and do is label my vertical asymptote. So keep in mind, the only transformation I have is a vertical stretch. Okay, so from here, I have all the asymptotes will stay the same. So I had pi over 2 and every distance of pi, right? Because from here, from this vertical asymptote to this vertical asymptote, I have a distance of pi. So if I do the same thing, if I have that same distance of pi, I can go ahead and see that it'll land right over here. Next, we're going to go ahead and see that, hey, originally my parent function said it was at -1, but now it's at -2 because it got stretched vertically. So if you are still struggling with -pi/4, you could actually go find it. -pi/4 is right over here, -45 degrees, and my coordinate is 1 and -1. If I do my y over x, I get -1 over 1, which is -1, times the transformation times 2. That gives me -2. So that's how I was able to find these right here. Okay, so look how my curve is starting to show, and we can go ahead and follow the same pattern, like so. Okay. Awesome. Okay. This one right here is going to go ahead and mess us up a little bit, but not too much because we know how to identify these horizontal transformations. In this case, was a horizontal compression, meaning that instead of my period being what it usually is, instead of it being pi, it's going to be some sort of diluted version. So it's going to be pi over my b. This 2 is my b. So now it's going to be pi over 2. So that's going to be my new period. Okay. Now from here, what the heck does that mean? Well, that's telling us that instead of it being a distance of pi and a distance of half a circle, it's now only going to be half a circle. So what I want you to know is that we're going to go ahead and decide that, hey, I'm going to still use my reference point, my y-axis as a reference point. So I'm going to go ahead and divide this one more time. So pi over 2, that reminds me of 50 cents. If I divide it by 2, my 50 cents become a quarter, right? So it's going to be pi over 4. Meaning I'm going to have pi over 4 on the left-hand side and pi over 4 on the right-hand side. Those will be my new asymptotes. Okay. Now, I know what you're saying. You're like, well, what just happened? Well, keep in mind this right here. Since I have my new asymptotes, and I saw that, hey, it went ahead and compressed by 2, it will go ahead and not be at pi over 2. It will now be at -pi over 4. So this right here is my pi over 4. And if I check the distance between -pi over 4 to pi over 4, this distance from vertical asymptote to vertical asymptote, that distance from here to here is pi over 2. And you can think about it like a quarter plus a quarter gives you 50 cents. Okay. Now you're probably thinking, okay, how does that change my graph? Well, let's find out. Since there is no vertical compressions, we can go ahead and see that the midpoint between our 0, right? Our 0 to our pi over 4 is pi over 8. That's just by dividing by half. So ideally, the shape, it will still be the same. So I'm going to go ahead and see that it goes from here, then to our midline, then to our 1, then back up to infinity. So like that, I go ahead and see that this shape will go ahead and continue to be reproduced throughout the entire graph. So let's go ahead and find out the remaining parts. So that I have pi over 4. This right here is 3 pi over 4. This right here would be pi. Then this would be 5 pi over 4. And last but not least, 3 pi over 2. Now keep in mind, you will have asymptotes every distance of pi over 2. Meaning, like so. Okay. So continuing our graph, continuing the same shape, we can go ahead and see that we follow the same pattern. but hopefully you're able to see that, hey, this right here, I can go ahead and see already that there's way more curves than what I was used to in the previous example that did not have any horizontal compressions. So we can go ahead and see already. Well, hopefully you can see. If not, I will show the two curves next to each other, the following. So look how many we already have. We have 1, 2, 3, and then this half and that half, that's 4. So we saw that this one had 4, and the previous one that did not have any, that was our basic tangent function, just had 1, 2. Okay, that's pretty awesome. So that's how this horizontal compression worked. We went ahead and compressed it by a factor of 2, so we had way more graph in there, right? If you will. Okay, a little meme for us. This one is actually one of my favorites and my students' favorites from last year. So hopefully you guys like it. Thanos, because of his chin, has already the vertical asymptotes written for us. So hopefully you guys enjoy that one. Gets me every time. Okay, this one right here. Let's identify this transformation. I got this negative pi over 4. This negative means it's going to be a horizontal shift, but it's going to be pi over 4. The minus, everything inside the parentheses lies to you. So it's going to be pi over 4 to the right. Okay? Meaning that how we normally have our units, everything, specifically the asymptotes, are going to go ahead and shift to the right. So let me go ahead and do that. This right here is negative pi over 2. Keep in mind, guys, these right here, if you still don't know how I'm getting them, I'm actually getting them from our unit circle. This is pi over 4. If you do not know those notes, I have a video about that. If not, all I'm doing is I'm adding pi over 4. I'm adding like a quarter to this, right? What did I say? 3 pi over 4. Then I got pi, then 5 pi over 4, and then I have 3 pi over 2, which is the same thing as 6 pi over 4. Okay, so ideally I have my vertical asymptotes right here, but in this case, keep in mind everything got shifted to the right pi over 4, so everything came to the right. So now instead of it being here, I have one here. Now the trick to this is that now my period is still pi. Okay? My period is still pi, so instead of it being pi over 2, everything just shifted one more unit. Nothing else changed. And I continue doing my same thing. So this negative pi over 4 was negative 1, but now it's going to be when radian is 0. And I just do the exact same thing. And hopefully you can go ahead and see that the shape still maintained its integrity, even though it was shifted horizontally. It was not compressed or stretched vertically of any sort. So ideally, you still have something like this. Okay. And this one was at 1. Something like that. Okay. I mean, not something like that, but exactly that. So from here, you can go ahead and see. Just that I'm here now that I'm going to go ahead and remind myself, let's talk about the vertical asymptote. What happens now? Well, the domain is all real, right? Except when you have an asymptote. So keep in mind, you pick an asymptote, I don't care which one, negative pi over 4. You add the period did not change because there's a 1 here. So my pi over b is the same thing as pi over 1. So my period did not change. So pi plus my value of any integer, right? Where p is an integer. P is a real number, right? It's a real number, or you can say integer, just b, meaning a positive or negative number, whole number. So pretty much that is what I have for you guys. Hopefully this helps in learning how to graph tangent. I know it's pretty easy to go ahead and just memorize a parent function, but I want you to go ahead and think about it the way I'm saying, so you can go ahead and identify transformations or shifts of any sort. But whichever one works for you best, I will help you out. Okay. For homework, I went ahead and gave you guys 4 graphs. 2 of them are very, very similar to what we just did in class. But hopefully you can go ahead and try some more on your free time. Other than that, guys, it was a pleasure to learn with you, and I'll see you guys on the next one. And thank you.